Welcome back to your math class. This is Jason Navarrete, and today we're going to talk about um, finding out the domain and range for some of the graph on functions. So let's start. So first is we're going to do this. We're going to talk about how you're going to find out the domain and range if you have just the equation. So I would like to share to you first what are the online resources that you could use for this. So there are two websites that you could use in order for you to graph your equation. And I'm pretty sure you are familiar with one of them. One of them is GeoGebra. So all you need to do is open your browser and go to GeoGebra and search for GeoGebra Classic. And then select this GeoGebra Classic, and it will direct you to this website that you can use to graph your equations. So you simply just have to type in your equation. So some of your equation looks like this: f of x is equal to, let's just say, x plus 1, x plus 2, which will show you your graph basically. Or you can just simply replace that f of x with y is equal to x plus 2. It's the same thing. Now, the other website that I would like to show to you is Desmos Graphing. You just simply have to search for Desmos Graphing and look for that Desmos Graphing Calculator. And it will show you almost the same format. So you have the keyboard right here for the symbols, for the letters and numbers. So those are the things that you can use. So for now, I'm going to use Desmos. So say, for example, the equation given to you is y is equal to, let's just say, x plus 7. Now the question is, what will be the domain and range for this line, for this function, x plus 7? So if you remember, domain are the x values. In other words, all of these values on the x-axis are the domain values. And if you'll notice as well, the line only goes from this point to that point. But if I am going to zoom that out, you will see that the line keeps on extending to both ends. What does it mean by that? Well, that means the value of domain here, or the x values here, are never ending. In other words, it goes from both ends. It keeps on extending from both ends. So here's the thing. What will be the domain for that? Well, the domain for that, as we know it, I'm just gonna type it in here. The domain for that will be all of the values of x. All values of x. And how do I know that? Well, simply because, excuse me. Simply because if I can select this point right here, or this random number right here, which is I don't know yet, and I trace it back to that line, you can find a point that represents that that value on the x here. And if I'm going to select another random point right here in between 200 and 300, right, somewhere in the middle, the question is, can I find that point on that line? Well, yeah, if you're gonna select this random point right here and trace it back to the number line, to the graph, you're definitely gonna find the point. And you might be wondering, what about this number right here, 500? Can I find it on that line? Well, if I'm gonna zoom it out, if I am going to zoom it out, 500, which is between 1,000, or no, 500, which is somewhere in between here, can be found somewhere here. Same goes with that 3,000. You may not see it right there, but if you zoom it out, 3,000, which will be somewhere right here, can still be found on that. So that's why I know for sure that the domain will be the all values of x. And how do you write down that how do you write that down in functions? So there's a special way for you to write it down. So the domain for that will be x is equal to the set of all x's wherein x must be less than or equal to the positive infinity, because infinity is going to this right. like the highest number that we can think of, is a positive infinity. So all of the numbers less than that, including that positive infinity, which we don't really know yet, are included to your domain. On the other hand, all of the numbers greater than or less than negative infinity are all of the domain. That means if this is negative infinity right here, if that is, let's just say this is negative infinity, and this on the other hand here is the positive infinity, that means all of the numbers from there going to the center and the positive infinity going to the center again are included. That means all of the domains are included to that set. This is just the special way for us to write it down. On the other hand, the question is, what will be the range for this? So what will be the range of values for that? So the range value, going back again, the range value are the y values. So we wanted to trace back, same as what we did with the domain. We wanted to trace back if I could find any of these y values to that line. So let's just say 200. Can I trace back the 200 to that line? Yes, I can. 100, yes, I can. Anything in between 200, yes, still I can. If I zoom this out, can I still find anything in between that here? Yes, still I can. 4,000 to 2,000 to 4,000, I still can. What about the negative? Negative 2,000 to 4,000, I still can find a line in between that. That means the domain for this, or the range for this, I'm sorry, the range for this are all values of y. Which also means bring you to the conclusion that the way you're gonna write it down is actually very similar to that, but instead you're gonna use y is equal to the set of all y, such that y must be less than or equal to, if this is the positive infinity, and this is negative infinity, all the numbers greater than the negative going to the center, and all of the numbers less than the positive infinity going to the center are included to the range values. So that is the meaning of that. So simple trick right here. So in other words, what I'm trying to say is this: if your graph represents a number line, I'm going to show you another example. F of x is equal to, let's just say, 4x plus 5. F of x is equal to 4x plus 5. It all obviously shows me a straight line again. Let's try another. If I have f of x or y is equal to, f of x is the same as f of that's the same as y, so I can use any of those. So I am going to use negative 7x, let's just say minus 10. And yes, again, I still have a straight line. If I zoom it out, it's still going to include all of the numbers that you can see. That means, in general, not all the time, in general, if your graph, if your equation, your equation, let's just say this equation, resulted to a straight line, in general, the domain for that are all of the values of x, and the range are all of the values of y. So that is the simple trick to that. So if your graph resulted to a straight line, that means all of the y values, all of the x values are included. So I hope that we learned something from the video today. Thank you guys for listening. You have a good day.